We have mapped the neural correlates of subjective experience down to the millimeter. We have clinical indices to measure wakefulness in comatose patients. Yet, as the volume of empirical data scales up, agreement on the nature of consciousness scales down. In a comprehensive 2024 taxonomy, published in Progress in Biophysics and Molecular Biology, Robert Lawrence Kuhn documented the scale of this fragmentation. He cataloged over 350 distinct, internally self-consistent theories of consciousness currently circulating in the scientific literature. These frameworks occupy an immense spectrum. On one end, neurobiological models reduce experience to synaptic firing. On the other, theories stretch into quantum mechanics, panpsychism, and idealism. Among the physicalist approaches, integrated information theory, or IIT, provides a mathematically rigorous framework. IIT proposes that consciousness is identical to the amount of information a system can irreducibly integrate, a value called phi, focusing on measuring complex structural capacity. By contrast, Global Workspace Theory, or GWT, dominates the functional perspective. GWT argues that consciousness occurs when sensory information is selected and broadcast globally across the brain's networks to separate cognitive modules. Both IIT and GWT have achieved immense empirical success in predicting specific brain states. However, their core foundational assumptions, structure versus function, remain logically incompatible. This fragmentation is a structural result. Like the classic parable of the blind men describing different parts of an elephant, each theory captures a partial slice of a deeper reality generation process. Researchers frequently treat all 350 frameworks as competing answers to the exact same question. This is an architectural misunderstanding. An operating system does not compete with a web browser. The OS simply provides the underlying rules and runtime environment for the browser to function. In 2026, researcher Yuxin Zhang published a framework called Selective Reality Theory, or SRT. SRT functions as a Meta-Ontological Operating System. It provides the formal mathematical substrate that allows isolated theories to mutually translate their findings. This system allows us to express the valid insights of each theoretical camp in a unified grammar, revealing complementarities hidden by their respective ontological assumptions. To unify the science of consciousness, we must identify the generative structure that makes all these different partial measurements simultaneously true. SRT replaces the binary of existence versus non-existence with a three-stage generative pipeline. It begins with L0, the latent domain. L0 represents a dynamic, high free energy state space of pure physical potentiality. Potentiality is drawn into reality by a selection mechanism, the ghost operator. This operator acts as a parameterized filter, forced to compress infinite potential into a manageable state. The output is L1, the manifest domain, an immediate experiential slice. These slices feed into L2, the convergence domain, stabilizing into a shared consensus reality. Reality is an active, multi-stage projection system that requires a localized operator to function. Anchoring potential into a manifest reality requires the continuous dissipation of energy. SRT formalizes this cost as ontological friction. This follows Landauer's principle, which states that any irreversible information processing, such as selecting one specific reality from infinite possibilities, generates a minimum thermodynamic cost. The wider the bandwidth of reality an operator attempts to process, the higher the friction cost it must pay. The formal metric for this ontological bandwidth is the D-value, or existential stake. The D-value is a substrate-independent thermodynamic metric. It measures how many variables a system must incorporate into its selection strategy to maintain its existence. Existence requires a metabolic and computational budget. A system cannot expand its awareness without paying the thermodynamic cost of friction. This Meta-OS architecture installs theories into operational nodes. Integrated information theory maps to the ghost operator. Phi calculates hardware capacity. Global Workspace Theory maps to the L1 threshold. Ignition measures runtime execution. The free energy principle maps to L2, describing rules stabilizing consensus reality. In 2023, the Cogitate adversarial collaboration attempted to pit IIT against GWT in a definitive trial. The experiment yielded mixed results. The Meta-OS mapping explains why. IIT successfully predicted the structural hardware capacity of the subjects, while GWT successfully predicted the execution of their perceptual states. These theories were never mutually exclusive. They are complementary components of a single computational architecture, analyzing different stages of the same pipeline. A valid meta-theory must generate novel, falsifiable predictions that the individual theories could not produce on their own. SRT achieves this with the Convergence Triad Theorem. It states phenomenal consciousness requires the multiplication of structural capacity, phi, and existential stake, the d-value, to exceed a critical threshold. Modern large language models rank high on the graph for structural integration. They process and integrate vast amounts of information. However, because these models face no survival threats and pay no thermodynamic friction to maintain their states, their d-value is 0. They possess pseudo-experience, massive information processing that fails to cross the threshold of consciousness. Contrast this with a nematode facing a predator. Its structural capacity is low. The survival threat pushes its d-value high enough to cross the critical curve, generating primitive subjective experience. High-level information integration without existential thermodynamic friction is merely reckoning. It is not conscious judgment. These protocols move SRT from theoretical speculation into empirical science. We can test this theorem in a laboratory right now. The Perturbational Complexity Index, or PCI, is a direct proxy for measuring phi. It calculates the algorithmic complexity of brain responses triggered by magnetic stimulation. Simultaneously, we can measure a system's d-value using behavioral metrics, like temporal discount rates and responses to survival threats. The falsification condition is specific. If systems with high structural complexity but zero existential stake exhibit greater markers of consciousness than low-complexity systems fighting for survival, SRT fails. Selective reality theory reframes the study of the mind as an extension of fundamental physics. It suggests consciousness research does not belong solely to biology. By translating subjective experience into the universal languages of thermodynamics and information geometry, we have the engine to map the true landscape of consciousness.